So I've been working on creating a horse run solar fan. Here's a horse run, several hundred yards away from the nearest barn or electricity. So I initially created an outrig for the structure to hold that one. That post behind it allows it to put at different angles. Hinged frame behind it, wired directly to a 3-speed fan. However, the problem in Michigan, you can see lots of clouds, very little blue sky, you can hear it cycling on and off, and it's inconsistent. So, put a pole in, a 16-foot pole, and I'm working on installing the frames right now. I have it bolted to the 2x4 or the 4x4. I have two plates. One is bolted to the 2x4, and then the other one is bolted to a 2-inch pole that's bolted to the first plate. I'll go up there and take a better shot. And then it's about a 5-foot pole where I'm installing the 2 solar panels. That will run a wire down inside the horse run where there will be a battery backup. So up here I have this plate bolted, 2 different plates. This plate is bolted to this post, 2-inch pole. This plate is also bolted to this 2-inch pole, which is bolted here. So this one allows it to move more toward the south or what have you. And this one will help align to a 35° per Michigan latitude recommended by solar companies. The panels themselves, there's a hole in each one, 1/4 bolt. Panels are relatively light. I'm just bolting those onto this C-channel. And then I will take the wires, connect them together. They'll go into the barn. With the first panel installed successfully, I will now take down the other panel and stick it up there. This is how I had the first one up. It was bolted to a couple 2x4s, which was bolted to this frame, hinged down here, and bolted to the panel. And then this allowed you to vary the angle, which I later found out could be set at 35°. But I'll take these bolts out and get this panel mounted up there. So I've got the second panel mounted. So both of them are up here. I also added a bar to make it a little bit more rigid, which still moves a little bit. We'll see what happens in the wind. And then I have a splicer that was supplied, so I'm taking 2 of the 2 positives. I know they're positive because it says there, and it's a Poka-Yoke system where it can only plug in this way. This is opposite of this, so makes it really easy. And then another positive, and then the negative to the other negative. Anyway, so be able to plug this in, run that down and over. Now I'll confirm 35°. Lock in this rotation. So right now it can rotate a little bit hard with a single hand. Lock that in. Okay, with both panels up there, wire coming down, running along, goes in right there, comes in there, goes over to the battery system, which is indicating a charge, low amps, but still a charge. It's off. Battery voltage is at 13.4, 21C. It's turned off. Turn it on. See what happens to the fan. Fan is on. running consistent, very consistent. You see it's very cloudy. Earlier it was maybe even less cloudy. But so the two panels have definitely eliminated the cycling on and off. So in theory, that will charge the battery fully. It's an 18 amp hour battery. 18 amp hours, that's a 65 amp fan. So run less than an hour after the sun goes down. But as the sun tapers, it'll still be getting a charge. I did direct it a little bit off of south because it's cooler in the morning and it's less required, less important in the morning. Fan is still running full blast. I think we achieved what we set out to achieve. That hangs down a little bit. I guess I could move that up so it doesn't hang down. Yeah, I think I'll do that. Let's see. I'll move that up. Otherwise, I'm happy with the entire setup. Yay. So the whole system cost, with installation, the pole, all the wiring, fasteners, it's about $2,100 to run power 200 yards. It would have been a 12.3 because if you have this, you might want to get more. 12.3 out here, a box. You're probably looking at, with burying the wire, 4,000 or so. So it saved a lot of money, plus it's free energy. Alright, thanks for watching.